Hey there, so what we're going to do is we're going to talk about how to solve similar triangles. And so to do that, we like to use the statement because I know the statement will never lie to me, okay? Sometimes the triangles look like certain things, and so I would rather use the statement to help you figure that out. So when we do these problems, what we like to do is we like to pick some just random sides, okay? So for example, if you look at this triangle up here, if we look at FE, FE goes with RQ. And I know that because they're in the statement in the same locations. So if I come over here, I would write FE over RQ. Okay? So that means that I would do 26, because that's what FE is, over RQ, which is 8x plus 1. Okay? Now, the thing about proportions are that whatever you start with, you have to start with in the other one as well. So if you're looking at starting with FE, then you have to start with FD when you create this proportion. Okay? So sides are always going to be proportional, so that's why we create these ratios. So FD is going to go over RP. And the reason why is because their letters are also located in the same area, okay, inside of our statement. FD, RP, okay? So 24 goes over 60. We're going to cross multiply. That's how you solve these problems. Now, when you do that, you need to put parentheses around your expressions if you have some. And so what we do is we do 60 times 26, and that gives you 1560. And that's going to be equal to, and you have to distribute this, so you have to do 24 parentheses 8x plus 1 and close them. And then you distribute that baby through, and then you'll have 1560 equals 24 times 8, which is 192x. And then you do 24 times 1, which is positive 24. And then all you got to do is solve for x then. So the big thing about all of this is just setting up these proportions so that they outlie the statement. Don't let the triangles fool you. Okay? Use the statement to help you set those up. So subtract 24 from both sides. That's going to give you, I'm going to do it in a calculator to make sure we're right, which is 1536. And you're going to set that equal to 192x. That means you're going to divide these off. So you divide that 192 off. And that gives me x equaling 8. So that if I plugged x back in, that would give me the ratio that makes this proportion work. Okay? So this is how you solve similar triangles. Let's do another example real quick. These triangles are connected, but that's not a big deal. Again, you want to find two segments that you can put together. So I'm just going to look at this big triangle first. So I'm just going to pick one. And again, it doesn't matter which one you pick. It's up to you. So I'm just going to start with 15. So I started with 15, which goes with FE, right? So FE up here goes with ES because they're in the same location, right? So ES on this other triangle is 10. So we will put 10. And if I set that equal to something, I have to set it equal to 30 because 30 is my other piece of information from my first triangle that I picked from. So like whatever triangle is on the top has to be the same triangle that's on the top on the other side. That means that 2x minus 8 goes on the bottom. And let's just check and make sure though, right? Because sometimes we're given all three pieces and we have to know that. So FE goes with ES. EG, which is their outsides, go with ET. Well, guess what? ET is 2x minus 8. So you'll cross multiply. So you'll do 30 times 10, which is 300. you'll set that equal to 15 parentheses 2x minus 8. And you'll close them. Make sure you distribute, so you have 300 equals 15 times 2, which is 30, minus 15 times 8, which is 120. And then we'll add that 120 to the other side. That's pretty rough looking, but we're adding 120 to the other side. And that gives me 420. And that equals 30x. Okay? So then we're going to divide by 30. And that's going to give me what x is equal to. So when I divide those, that gives me 14. Okay? So that's how you do similar triangles. What I suggest you do is just pick one side, and it doesn't matter which one you start with. So the big thing is, like, I could flip-flop this 10 and put it on top. But if I do that, then the 2x minus 8 has to go on top. Again, whatever triangle you start with has to be the same on the top, okay? And you just match up the letters from the statement. The statement is key. Always use the statement when you're setting up these proportions. Don't look at the triangles, because sometimes you can get confused about what's actually happening in the triangles. So please pay attention to the statement to help you do that.